Hello, everyone. Welcome to today's webinar. My name is Claude Doheny. I'm the Senior Content Marketing Manager at Digital Niche Agency. Today, we have the team of Carnot Compression team. How are you guys doing today?
We're doing good. How are you?
Doing amazing. And we'll give some time for people to, come on in. But before we dive into the presentation today, I wanted to open the floor for you guys to kind of introduce yourselves and, kind of explain a little bit to the audience today what the webinar is all about.
Okay, great. So I'll kick that off. I'm Todd Thompson, one of the co-founders and the CEO of Carnot Compression, and want to thank everyone for joining our second and last investor webinar of our current capital raise. And today we're going to be introducing the team, talking about the company, and talking about our plans for 2023. With me, I have Hans Schillinger, our COO, one of our other co-founders, Christophe Duchateau, who's our principal engineering scientist, Ifat Hassan, who is an intern, and Chris Finley has joined us. He's our VP of engineering, but Chris is a bit under the weather, so he's on mute.
Awesome. And I do want to thank the audience for tuning in today. This webinar is for you, to learn more about, Carnot Compression, what they're planning on doing this year, and talk a little bit about what, how 22 went and, see their plans for 2023. And, they're currently running a campaign on Start Engine. That campaign is not going to be running forever. So if, after this presentation, you want to learn more, highly recommend visiting the Start Engine page and checking it out and see if it's something that you are interested in and want to learn more. So with that being said, Todd, take it away.
Okay, thank you, Khalil. So again, thanks everyone for joining us. And I'm going to talk a little bit about the company and our plans for 2023. Carnot Compression is commercializing a more environmentally friendly, lower cost air and gas compressor technology. And our mission is to lower the carbon footprint of industry by reducing energy consumption from compressors and doing so with a completely oil-free process. A second here. So the agenda, we've already introduced the team, so I'll quickly go through that. We have a company presentation for those of you that were in attendance for our last webinar. Much of this will be review, but we do have some new content as well. And for those of you that were not in attendance on our last webinar, you can view a recording of that up on our webpage under the blog section. So again, I'm CEO and co-founder. I've got 25 years of experience, finance, corporate development, strategy, M&A. I've worked in consulting. I've worked for large companies and co-founded Carnot Compression back in 2014. And I'm a UVA grad. With me, we have Hans, who's our COO and co-founder, 30 plus years experience in engineering, much of that time with Quanta Services, a big engineering and construction firm, and Hans is a Cal Poly grad. We have Chris Finley, our VP of engineering, who's got 20 plus years of mechanical engineering experience, background in cryogenics, rotating machinery, went to the University of Nevada, Reno, and worked quite extensively for Ibarra International. Christophe is our engineering scientist. He's a PhD with a postdoc at Stanford and began his career at Bechtel before joining us. And last but not least, we have Ifat, who's a PhD candidate at the University of Nevada, Reno in mechanical engineering. So a little bit about the company background. We've primarily been funded with non-dilutive grant money from the National Science Foundation and from the California Energy Commission. We've completed about $3.5 million worth of grant-funded projects. We just kicked off a $2 million grant with the California Energy Commission last spring, most of that which is still remaining to be spent. We raised $950,000 in a first round on Start Engine and closed that out last spring. And we're on our second round. We've raised over $100,000 so far and we will be closing this round in 2 weeks from tomorrow. We are beta testing our product. We'll talk a little bit about that today. And we've got a broad IP portfolio of issued patents, pending patents. We've trademarked the Carnot compressor, and we have a wealth of knowledge in the form of trade secrets from the 10 years or so that we've been developing the project. So really, that's important. We've taken this from concept to a commercial device. And, we'll get into more detail about where, not so much about where we've been, but about where we see ourselves headed into the second half of this year and beyond. So why is what we're doing interesting and important to us? Well, you don't hear a lot of startups going after the air compressor industry. It's a pretty mature, kind of conservative, a lot of people would say boring industry, but it is ubiquitous to manufacturing, to a lot of small businesses, to agriculture. It's called the fourth utility. So after power, gas, water, there's compressed air for running a manufacturing operation, for running a food production plant, for running an auto shop, for painting a car. So pretty much, I'd like to say everywhere that something is made, there's an air compressor somewhere in the background. Most compressors in operation are oil flooded. So basically that means that within the compression chamber, whether it's a rotary screw compressor or a piston compressor, there's oil in the compression chamber to handle the friction and to handle the heat that's generated from compressing a gas. Despite many customers, best efforts to filter out the air as it leaves the compressor, there tends to be a lot of carryover in the compressed air stream from oil flooded compressors in the form of oil. A lot of industries, notably, food and beverage, dairy, auto painting, can't tolerate any oil carryover in their compressed air stream because it will damage a product. So for those customers, there are oil-free alternatives in the market today. What we find is that those alternatives are much more expensive than similar sized oil-flooded counterparts. They're higher operating costs, less efficient, and they've got a shorter operating life. So we'll get into a little bit about the inspiration for the technology and how we've adapted it. So Hans, you want to take this from here?
Sure. What you're looking at here is a patent drawing from Charles Taylor. I can't remember the date on this, but it's late 1800s, early 1900s. This was for a mine scale compressor that was the first and inspirational design for what's called a Carnot compressor. What you're seeing on the left is a river essentially that is flowing, and Mr. Taylor cut a vertical shaft about 300 feet deep, 15 feet or so in diameter, down into the bedrock. They had a chamber that was some 800 or 900 feet long and 30 or so feet high, just a big open chamber. And then they had a tail race going off to the right that went underneath a shelf and returned water back out to the river. Now, what happened here was as water fell in from the left-hand side, it was mixed with air, and those two combined in a frothy mess for 300 vertical feet and compressed. When that happened, the heat of compression was instantly transferred to the water, and the trapped air was in the chamber was essentially the same temperature as the water. So all of the heat of compression was removed. This means that the air is still saturated with water vapor, but it's at a much lower temperature than typically a piston compressor or a screw compressor would have in their exhaust. So what that meant was there was a very low moisture content in this water. This particular mine operated for some 80 years without, I think, with one maintenance stop someplace in the middle, and produced somewhere near 5,000 horsepower nonstop 24/7. So storage thing. It's in the ground. It's not going anywhere. So unless you're right next to a resource like this, you can't really take advantage of it. Could you flip back, please?
Sure.
So what we've done to turn this into a rotary device is you can see the little red arrows up on top. If you take this whole cross section and you spin it along that axis, rather than have a single G, what we did was replace that G with a rotary device and centrifugal force. And so we're using the centrifugal force that's generated on the water to increase the amount of pressure that we're able to generate in a smaller space. So now you can move. What we've come up with is this, where we're taking a small drum, which is the interior rectangle, and encasing it in a containment device, which is the outer one. The drum on the inside spins at somewhere between 2,500 and 4,000 RPM, and we fill it with water. And the water spins into an annular donut on the outside of the drum. And then we use a pitot head, which is the purple piece with the blue arrow next to it, to reach out into that lake and pull water out that we run up through a pipe and down through a nozzle and through an eductor and down into the center of our device, where that as the waters pass through the nozzle and through the eductor, it pulls air in, which is and that forces an air and water mixture down inside the compressor, and that is spun out through a series of channels into the lake on the outside edge of the drum, where the arrow changes from green to orange. That's where that emulsion is compressed. We then capture the air, the compressed air, and route it back down through the center of the device out the bottom and collect it for use. And then the water stays in the drum and returns to the top and runs in a loop. We have an outside loop that is attached to this that we extract heat with to keep this at a fairly low but constant temperature. This is inherently oil-free, as you can tell. There's nowhere in here that water or that oil comes into contact with anything. So it's quite a clean process. There's only one moving part, and so the maintenance on it should be fairly minimal. There's not much to go wrong here. So that's the theory on what we're doing.
Thank you, Hans. So big picture, what's the opportunity here? Our goal is to have an oil-free compressor with lower lifetime cost and reduced energy usage versus not only comparable oil-free compressors, but against oil-flooded compressors as well. We're looking at a market that's about 40 billion annually in sales, according to third-party research. Roughly 1/3 of that market is oil-free and 2/3 is oil-flooded. In terms of unit sales, about 75% of the units sold are under 50 horsepower, which is our sweet spot in terms of where the technology is expected to be in the next couple of years. Let's talk a little bit about our impact. If you look in just the US alone, there's approximately $12 billion spent annually on energy costs to power compressors. We believe that the technology has a very high ceiling in terms of the efficiency potential it can reach. If we hit our efficiency potential, there's 20% plus savings opportunity versus what's on the market today. So you just play out the math, that could represent an opportunity of over $2 billion in the US if we were to replace every compressor in the market with ours. And if you look at the global opportunity, take that math and multiply by about 6. So the value proposition is really about providing a lower lifetime cost of ownership, not just with energy savings, but with lower maintenance cost and a longer operating life. Again, our initial target market is the 5 to 25 horsepower oil-free compressed air market. That's a market that is about 3x in terms of first cost versus comparable sized oil flooded machines. But long term, we think there's a significant scaling opportunity as well. And we see the technology reaching levels of hundreds of horsepower over time. So I'm going to talk a little bit about some of the partnerships that we have. For those of you that have been following us, you've seen some announcements in the past, but we've been working with both Monroe and Associates and Oak Ridge National Laboratory. Both of these projects are funded by third-party agencies, the California Energy Commission and the U.S. Department of Energy, respectively. So Monroe and Associates, they are a consulting firm that has a proprietary process called lean design. And basically what they do is they assist companies all over the place, primarily in the automotive industry. That's where they started, but very broadly within manufacturing, to analyze the design of their systems and design it for low cost, design it with servicing and maintenance in mind, and design it for long operating life. So we went through a lean redesign project with Monroe the second half of last year. We shared with them the design from our beta unit compressor and went through a series of workshops to look at opportunities for getting the BOM cost down and having a more robust, longer life machine. So some of the key highlights there, we identified a 32% reduction in parts count versus the baseline beta design, and a 39% reduction in projected manufacturing cost versus the baseline beta design. And those are improvements that can be implemented this year. So as we go through our beta test program over the course of the year, we will be implementing these design improvements, and that gives us confidence that when we are ready to go to first production, that we will have a machine that can be manufactured on a very cost competitive basis. The next partnership that we have is with Oak Ridge National Laboratory. Christoph, you want to talk a little bit about what we're doing with Oak Ridge?
Yes, sure. So with Oak Ridge, we basically contacted them about CFD, which is computational fluid dynamics simulations. The main idea is that we have had some issues in the past in terms of how well our in-house CFD efforts were working for one part of the device. And basically they have more resources than we do when it comes to testing various software suites and computing power as well. So we really hope that they will provide us with ways to improve our simulations and improve the design of that one part of the system. So the main objective will be to increase the airflow within our current footprint, to improve the efficiency level, and as well be able to scale to much higher output levels. And as Todd was saying, this part of the project is funded by the US Department of Energy, and it is at no cost to us.
Okay. Thank you, Christoph. So now let's talk about our key objectives for 2023. And this is a very exciting year for us, a very exciting time in the company's life cycle, where we see ourselves transitioning from the R&D/product development stage to product commercialization by end of year. And really the year as we see it is broken out into two main phases. The first phase is extended field testing that is in place and ongoing in the dairy industry right now. We're looking to have other field tests come online over the course of the year. And with that field testing and the lessons learned from having machines out in operating environments will lead to low rate initial production capabilities by the end of 2023. And that's really our goal, is to transition into the second half of the year, proving out the design in the field and ramping up to deliver our first commercial units by the second half of the year and into 2024. And then as we get into the end of the year, we intend to have channel partnerships in place to support a much broader commercial launch. Those discussions are ongoing as we speak, and the big objective here is to flesh those out and formalize those partnerships over the first half of the year so that we can support that launch again into 2023, beginning of 2024. So one of the big target market opportunities for us is the dairy industry, and specifically to supply oil-free air for robotic milking machines. This is a very large market that is largely off the radar screen if you're not in the industry, but there are 70,000 plus robotic milking machines estimated to be installed worldwide, and that's growing about 20% per year. If you look broadly at the dairy space, the robotic milking machines are still a very low market share of overall dairy operations. So there's still a lot of upside there in terms of driving that installed base. These machines need a continuous supply of oil-free air to run their pneumatic systems. And what they have today has a low operating life in terms of needing a major maintenance or a complete replacement for their system, because they require 24/7, 365 airflow streams. So we've had multiple customers come to us seeing our design as a potential solution to a current problem that they have. We are executing 2 test projects with dairy specialists, and we see this as a very exciting near-term market opportunity for us. Another early adopter market that we see is in automotive painting. And quite simply there, when you run a paint sprayer, if you have any oil that carries over in the compressed air stream, it can damage the paint job. You see all different kinds of stats, but we conservatively estimate there's over 60,000 auto paint shops in the US. And we have a beta test project lined up in California at an auto body shop, and that's funded by the CEC. So we see this as a really attractive early adopter market opportunity for us as well. So big picture, 2023, extended field testing, continuing to refine the product, formalizing the channel partnerships, and establishing low volume manufacturing capabilities. And we see that leading to a soft launch by the end of this year, early 2024, within the 5 to 25 horsepower oil-free segment. As we head into that launch, we're looking to expand the team to support broad commercialization, and that would be expanding the team both internally and through partnerships. And over the course of 2024, we see that as the next transition from that low rate initial production to larger volume manufacturing capabilities. And that leads us into more expanded sales channels within the US. And we've had a lot of interest from international partners as well. So as we go through this path, there will continue to be product development. There's still a lot of upside opportunity in terms of scaling the airflow of our machine and reaching those upper limits of efficiency that we see as very possible. And we're very excited about the path ahead of us in terms of the ability to really bring this technology that's been in R&D mode for a while to the world and into the marketplace. So with that, I'll sum up. We have very unique proprietary technology with a very high impact potential. We've got broad patent protection on it. We are in beta testing. We funded the company. We've gone from founders, friends, and family to grant funding to seed funding. We're on our second raise under Reg CF, And we have, in addition to the equity we're raising, we've got the majority of our R&D expenses covered over the next couple of years through a grant that we have with the California Energy Commission. And as I said before, we are raising on Start Engine. That's the platform that we're raising through ReXCF. You can go to www.startengine.com/offering/Carnot Compression to learn more. And we will be closing out the raise on February 3rd. So all the details on the raise, the offering materials can be found on the Start Engine site. So with that, I will open it up to questions.
Yeah, and we already see questions coming in, and just, quick disclaimer, due to SEC guidelines, there's some questions that unfortunately we cannot answer on this live event. That's, anything pertaining to the financials, use of proceeds, future projections. If you want all that information, please visit the raise page. All that information is there. So just on this webinar, we're not allowed to discuss that. The first question I see here is, you're using high-speed water stream to entertain air, correct? How do you ensure enough air volume is compressed, and how do you make the entertained air to separate from the water stream? Why is this machine more energy efficient compared to normal blowers or compressors relying on impellers?
Hans, you want to take that?
Yeah, I'll take a whack at it here. You've asked a big question, actually several
Questions.
Yes, we are using a high-speed stream of water to compress the air, or to entrain the air. We're running that through a fairly well-known device called an eductor. They're very well documented in terms of what they can pull in. Both, you have to have the entry and exit conditions as known, meaning the pressure and flow of the water going through a known orifice size, passing over a gap. You can very accurately predict how much air will be entrained in the stream as it's pushed downstream. Separating the air and water, we're essentially running a centrifuge. The real challenge is to try and get the air out into what we call the annular lake, and then get it to a place where we can capture it. But once the air water mixture hits that annular lake, it takes very little to separate the air from the water. It wants to float right back to center. As far as efficiency is concerned, we're not there yet, but what makes us more inherently, or gives us more inherent potential, is the fact that we're isothermal in nature. Mm-hmm. Because of that, the curve of efficiency that we can hit, it gives us about a 20% opportunity to exceed what's currently on the market. So I hope that answers the question briefly anyway.
Thanks, Hans. So I see the next one is asking about our patents. Yep. So basically we have 5 core patents that are in various different stages. Whenever we file our IP, we always file first in the US. Then we choose to file internationally in, target markets. We look at basically the opportunity for our technology in the international marketplace. So I couldn't tell you how many issued versus pending that we have globally, but we've got 5 core patents that have all been filed in the US, and several of those have been issued in the US, and many of those have also been issued in international jurisdictions.
Awesome.
When do we expect to be out of beta testing? This year. So during the course of this year, we will be beta testing. We're beta testing right now, and we expect to be out of beta testing this year and looking at initial production by end of year.
Awesome. And then how does the water turbine design compare to other oilless compressors in sound noise levels during operation?
Okay, so noise levels, we are under 70 decibels, I believe. Is that right, Hans, Christoph? With the containment?
Christoph, I think, has the number actually. It's probably noisier right now than what's being used, but we're pretty much out in the open with it. We haven't gone to great extents yet to really enclose it and insulate it. So some of the sound we're getting right now is going to get dampened down. So it should be competitive.
Okay. So size of motor in use on the beta test, what CFM, what pressures. So we're using a 10 horsepower motor. We're running about 115 PSI, and we are testing different air in components in terms of airflow. And those have ranged from single digits to low double digits in terms of CFM on the different components that we've tested.
Our present effort with ORNL is aimed directly at that question, though. We have identified a spot in our system that hydraulically has been difficult, and that's what we're working with them to resolve. We feel like we should, once we get past that, we should be in a position to put out competitive CFM.
Yes, both in terms of more CFM within the footprint of our drum and also using less horsepower within that same size drum. So is the Carnot compressor compatible with food industry standards? We haven't tested there yet. We can say the quality of the air in terms of the amount of oil and the amount of moisture that exits, we think will be very high. And we don't see any issues in terms of being able to filter out any remaining moisture to reach very high dew point levels. And I don't see really any other issues that would keep us from meeting any food industry standards that are out there.
Then when you say isothermal, won't water absorb heat, which lowers the air temperature? Water has a very large heat capacity.
Okay, I'm not
Christoph,
sure.
you want to take that?
Yeah, sure. So basically, as we compress the air, the heat goes to the water. So basically, the entire compression occurs at the temperature of the water, which typically for our compressor is about 120 Fahrenheit.
Okay, so Tilibay, how happy is Tilibay with performance of the beta units? A lot of questions there. So I guess what I will say is, that's a first of a kind unit that's been implemented in the field. We've had some issues with shaking the unit out, primarily with an OEM part that has failed, that has caused us to go back and do some redesign. We are confident that we will reach our efficiency targets in terms of reliability and in terms of generating enough airflow to run one of their robotic milking machines. But we haven't tested that yet because of some of the shakedown issues, or we haven't proven that out yet because some of the shakedown issues that we're undergoing right now. When will we have a beta unit generated with the redesign? I guess that refers to the redesign with Monroe. That complete redesign unit will probably be in our first test unit under the CEC grant at the auto body shop. So that's probably late this spring is what I would say.
And then are you looking into any other partnerships aside from the one you have with the dairy farm?
Yes.
And how do you envision selling the product? Internal sales team, strategic partnerships?
So I would say a combination of both. We're looking to leverage partnerships within the existing ecosystem of both, compressed air distributors, as well as engineering and design firms that work with some of these larger manufacturing companies and design in, compressed air systems into their plants. So we are talking to a bunch of different people, ranging from those EPC firms that design and spec products into the field, to independent air and gas compressor distributors, to companies that are specialists in certain industries. For example, dairy specialists. They do the install of dairy automation equipment. They install the robotic milking machines, and they package compressors to run the pneumatics on those machines.
Can you explain how this product would be used in the food/beverage industry?
Yes. So primarily, for example, in the dairy industry, it's for the instrument air to run the pneumatic machines. There's a lot of compressed air that goes into packaging food. There's a lot of compressed air that runs conveyor belts at facilities, just a wide variety of different uses.
And is your market primarily new build facilities?
No, I would not say so. The market, there's a constant churn of compressed air or air compressor replacements that are out there in the marketplace. So some of it is driven by new build, but a lot of it is driven by replacements as well.
Cool. I'd like to look at the patents in the patent database. To whom are they assigned?
Okay, so those would be assigned to Carnot Compression, Inc. So you can go to Google Patents and find pretty much everything that we have.
And then how soon do you think it will be until this is at a commercial state?
Okay. Well, again, as I said in the presentation, we see that transition happening this year. So end of 2023, we think we will have all of the field test issues shaken out, and have a design that can be commercial ready and go to production. And as I said before, we're looking at that soft launch, low rate initial production, early 2024.
Okay. How does the dimensions compare with compressors of same capacity?
It's pretty similar. Yeah.
And then how big are the current units as compared to existing compressors?
I would say same answer as the last question. They're pretty similar. Our beta unit is about 2.5 by 3 by 5, roughly.
Cool. If there are any other questions, please add them into the chat box below. I'd be more than happy to get those answered. We still do have a little bit of time. What has been the biggest learning opportunity of 2022, and how are you going to take those learning opportunities to incorporate them in 2023?
Okay. Hans, you want to take that?
Boy, there's so many things there to identify. I'm really excited about actually some of the progress that we've made here recently on some of the internals. That and tying in with ORNL is a real opportunity to kind of help push the most complicated part of this forward. The most frustrating part of this year has been mechanical things that I won't say don't control, but they're not central to our technology, and they've really gotten in our way. So, the big goal here for the first couple of months is to get past that roadblock so that we can implement the changes that we've been working on and really see this thing start to take off. It's been a long, slow grind, but we're right at the edge, and with a couple more pushes, I think we're going to be in a great spot.
Anyone else from the team care to answer that?
Yeah, I would say just on top of that, the issues that we've seen from the field testing has led us to what I think are better long-term solutions for the design. So You know, in an ideal world, you have this first of a kind unit, it goes out in the field and it works perfectly, but that never happens, right? So, you know, we had to push ourselves to get to the field testing stage to learn about the problems that we didn't know we had. And that's pushed us to find better solutions, which you know, is all part of the field test process, and that's being addressed as we speak. Which is kind of an answer to the next question: what do we focus on day to day? I mean, it's a startup, so everyone wears a lot of different hats, but it's a combination of engineering, it's a combination of testing the machine, modeling the machine, looking at partnership opportunities. I mean, there's just a laundry list of everything that needs to get done in the startup to push it forward.
And then we do have a question here in the chat that I didn't miss is, will the tests in dairy and auto painting be long enough to allow the industries to actually see significant energy and operating savings? Will you isolate the energy consumption to the compressors so they can see the results directly?
Yeah, so that's the goal with the you know, CEC funded project. Part of the project scope is to isolate the energy draw of the compressor versus the output that we're generating, and we're going to be doing that, you know, through cycles, you know, startup, you know, turn down, and continuous state operation. And you know, the test will be ongoing. So you know, we're looking to go to market, as I said before, early 2024, but you know, we will continue to test and refine in a parallel path between here and there as well.
You know, the compressor industry is an old industry, and most of the traditional designs have been around for a century, literally, and have millions and millions of man hours in improving all of the various bits and pieces and aspects of them. This is brand new. And so we're still at the stage where we're making changes that are going to have fairly significant impacts to efficiency in order to, you know, kind of reach up the learning curve here. And as we get through this, that learning will continue, and those efficiencies will continue to increase. They will probably increase at a slower rate, but I foresee this as something that's going to be improving continuously. It's not going to stop.
Mm-hmm.
And what are the economics compared to current air compressors, CAPEX or OPEX?
Okay, so we haven't finalized pricing strategy, and we probably won't until we're out in the market. But I would say initially our goal is to have first cost that's competitive with other oil-free compressor alternatives with lower maintenance and operating cost.
And are you doing any MTBF/MTTF testing, or do you think it's too early to do that?
So it's a little bit too early to identify the times to failure. We currently have on the testing in Tila Bay one point that is basically a seal that keeps failing a little bit too soon, and preventing longer term testing that would allow for identification of actual time to failure.
And will you isolate energy consumption in the beta tests so they can see the results directly?
And I think we already answered the question. Yes.
Awesome. You know, there aren't any other questions here, but I do have a question. What would you say are the top 3 to 5 reasons someone should invest today?
Okay. Well, the biggest is, you know, the market opportunity in front of us. We see, as we've said before at various times, you know, most of the compressors in operation, they're based on designs that are 100 years old. We've got, we feel, a much better mousetrap that's in an industry where there hasn't been anything new and unique and different from a customer's perspective. So we see a big opportunity to go in and provide a better product versus what's out there on the marketplace. And you look at a market that's $40 billion in annual revenue, with most of that market being oil flooded machines. You know, if we're able to flip that and have a better oil-free product, but also a product that will convert oil flooded customers to an oil-free product, then that opens up a really tremendous market opportunity for us. You know, we've in terms of risk from an investor's perspective, we feel that we've de-risked it significantly over the course of the last few years. So, you know, I think the big science risk has gone away. You know, this isn't really a science project anymore. The biggest risk now is our ability to get out and execute in the marketplace and address the engineering issues that need to be addressed to reach the ultimate efficiency of the technology.
Awesome. I'm gonna go ahead and add the Start Engine link here in the chat box below. As Todd mentioned, the campaign is coming to a close. So, you know, if you were on the fence of investing, I highly recommend to check out the Start Engine page and really get your questions answered directly there. And if you need to reach out to the team, feel free to do so. Do have, you know, we don't have a question, but we do have a comment saying, not a question. I've invested in both rounds. I appreciate all your hard work, your transparency and availability to the investors. I'm very excited to see the future for this opportunity. Good luck with your current efforts to improve the product. Thanks.
Well, thank you, Adam, and we appreciate your support and your investment. And thanks again to everyone for being on the call and for all the questions. And anyone has any other questions that they think of, feel free to reach out to me directly. Again, thank you for your time.
Thank you, everyone. And the webinar has been, you know, recorded. We will be posting a recap around it. So if you weren't able to attend today, don't worry, we will have you covered and we'll be posting that recap. And for those who did attend today, thank you very much. And yeah, be on the lookout for that recap, and you know, share this opportunity with your family, with your friends, with your network, and really spread the word of what they're doing there at Carnot Compression. Yeah, hope everyone has a good one.
Okay, thanks everyone.